Hi, everyone. Welcome to DrKwonGolf. In this episode, I will continue the discussion on torque. In part one, I introduced the concept of torque and also the concept of GRF torque in the frontal plane. So let's go back to this and then go over the idea briefly. So here's a golfer swinging. This is in the middle of the downswing when the lead arm is parallel to the ground. And this point is the center of mass of the golfer, which serves as the moving center of rotation. And then this is the ground reaction force, the combined ground reaction force, sum of these two ground reaction forces. And this line is the line of action. So the force is acting along this line. Then the separation between the center of rotation and the line of action, or this distance, is called the moment arm. So in this case, the torque generated is the length of the moment arm times the magnitude of the force. So the longer the moment arm is, or the larger the force is, the larger the generated torque is. And if we consider this as the body of a wrench, and then you push this point up, then it will turn in the counterclockwise direction. So this force generates a counterclockwise torque about the center of mass in this case. And this concept is important because torque is the cause of rotational acceleration or angular acceleration. So in order to accelerate your body angularly fast, then you should be able to generate large torque by using the ground. But actually in golf swing, this torque is only about the forward-backward axis in the frontal plane. But we also need a large torque in the horizontal plane about the vertical axis as well. So when you add these two torques, then this will be the total torque if we ignore this component here. So this is the resultant torque, and this shows the axis of angular acceleration. Although in part one, I mainly looked at this, but in this episode, I will focus on this component. And in part one, the reason why I only looked at this one is because this torque is actually the bottleneck. So this is the limiting factor. We can easily assess or characterize a golfer's swing by using this torque here, the torque about the forward-backward axis in the frontal plane. If the golfer uses the ground really well, then the golfer can generate large torque along this axis. But if the golfer does not use the ground that well, then the magnitude of this component will be limited. So that's why I mainly looked at this one in part one. But today, by including this vertical component as well, then we can have a more holistic view of what torque does in golf swing. So if we look at the horizontal plane torques about the vertical axis, there are two main sources. This diagram is related to the episode on ground reaction force. So when we interact with the ground, then basically this is done through interaction with the force and then interaction with the torque. We have a linear interaction and angular interaction. When you push the ground with the force, it's your action, then the ground acts a force, a reaction force to your foot. But because the reaction force is what changes the motion of the golfer, so we're only interested in the reaction force, not the action. This action affects the motion of the earth, but what we're interested in is the motion of the golfer, right? So this is called the ground reaction force. And then also your foot will interact, with the ground torsionally. So the torsion interaction with the ground gives this ground reaction torque, because you are exerting a torque to the ground. So the torque at the same time exerts a reaction torque to your foot, which is this one here. I added a circular arrow to show that this is a pure torque. But anyways, so we have the ground reaction force and the ground reaction force acting on both feet. This is the force acting on the right foot. This is the ground reaction force acting on the left foot. This is the ground reaction torque acting on the right foot, and then on the left foot. So considering this, we can basically identify two different sources of torque acting on the body in the horizontal plane. So this is the horizontal view. And the first source of torque in the horizontal plane is the so-called gyrative torque. So these are the individual gyratives, individual ground reaction forces acting on the feet. And this is the center of mass. So because the force is acting not through the center of mass, that means these are eccentric forces and they form moment arms. So this DL is the moment arm formed by the force acting on the left foot about the center of mass. And then this DR is the moment arm for the right foot force. But both cases, they're generating torque in the counterclockwise direction. So we'll have a net torque. So this is the so-called gyrative torque. And then, because we also have these ground reaction torques acting on the body, that means that we'll also get the torque. So the ground reaction torques are basically providing, torques to the body as well. So largely, we have these two different sources in the horizontal plane. But this torque can be further divided into two different ones, two different torques. So the next slide will show what they are. So in the horizontal plane again, first we can look at the torque generated by the combined ground reaction force acting at the combined center pressure about the center of mass. So this is the combined ground reaction force, and then this is the moment arm formed against the center of mass of the body. So this will give you the gyrative torque. The second one is the so-called pivoting torque. And this is produced by these two individual forces about the combined center pressure. So this force forms this moment arm relative to the combined center pressure. This force forms this moment arm against the combined center pressure. The combined center pressure serves as the balance point for the golf-ground interaction. So it bears importance. And so what we can do is we can add these two forces together and then use the combined force acting at the combined center pressure and look at how much torque is generated by the combined ground reaction force about the center of mass. So this is the torque that can be explained by the combined ground reaction force about the center of mass. And then this torque, this pivoting torque is the sum of the torques produced by the individual forces about the combined center pressure. In other words, this torque is the torque that cannot be explained by the combined ground reaction force. But if you add these two, then it's the same to the total torque produced by the individual forces about the center of mass. So I simply divide it into these two. And then the ground reaction torques can be added, and then I call it the foot contact torque. So essentially, in the horizontal plane, we have these three different torques acting. But among these, this pivoting torque is the majority. And then this gyrative torque and the foot contact torque are really small. So if I show you the relative magnitudes of these, in this graph, the red line shows the frontal plane gyrative torque. In other words, it's this one here, along the forward-backward axis. This causes a rotation in the frontal plane. So this is the frontal plane gyrative torque. And in terms of magnitude, is the largest. And then the green line is the total horizontal plane torque, or the torque about the vertical axis here. So MZ here. As you can see in the driver condition, this is a driver condition. And the gyrative torque in the frontal plane is a bit larger than the torque in the frontal plane, torque in the horizontal plane about the vertical axis. Also, what we can see here is that the majority of this vertical torque is coming from the pivoting mechanism. This blue line shows the pivoting torque. And then the GRF torque in the horizontal plane and the foot contact torque here is minimum. So most of the vertical axis torque or the horizontal plane torque is coming from the pivoting mechanism, the pivoting torque. And in this particular instant, the frontal plane GRF torque and the total vertical axis torque or the horizontal plane torque are equal to each other in magnitude. That means that this arrow and this arrow has this, the same length. And when you add these two, then this will be the actual torque. And then, so this serves as the axis of rotational acceleration. Now, at this instant here, obviously the frontal plane GRF torque is greater than the horizontal plane torque. So we see some differences here. So as a result, this arrow is longer than this one. So this angle is less than 45 degrees. So as the relative magnitudes of these torques change, the direction of this axis changes to a certain extent. But in golf swing, the main limiting factor is this torque here, the torque in the frontal plane about the forward-backward axis. But depending on how well you use the ground, you will see a large variation, a wide variation among golfers, in this one here. So if you use the ground well, then you can generate large torque in the frontal plane. But if your wave shift pattern is poor, if you don't work with the ground that well, then you cannot generate that much torque along this direction or in the frontal plane. So this torque really becomes the main limiting factor. On the contrary, we can generate this torque relatively easily. All you need to do is just spin your upper body. And when you use the muscles actively and then try to spin your upper body quickly, then you will be able to generate this vertical torque or the horizontal plane torque. So you can certainly generate more torque, but you don't, because if you increase this torque too much, then this axis goes more upright, going this way. That means the swing plane becomes quite flat. Your club head will miss the ball. So although we can generate more torque, in this direction, in the frontal plane, but we don't. Again, because of the direction of this axis. We need to align this axis, properly, so that your club head returns to where the ball is. And so, if you can generate the large torque in this direction, you can easily generate the matching torque along the vertical axis. So you can still maintain this axis. But because depending on how well you use the ground, this component will be limited. So then if you generate small torque in this direction, then you also have to generate small torque in the vertical direction to maintain this direction here. So in golf swing, really the frontal plane GRF torque becomes the main limiting factor. That's why in part one, I emphasized this particular component. But it doesn't mean that in actual golf swing, this is not important. You still need to generate large torque about this axis in the frontal plane. Okay? Now, if we compare different club conditions, this is the driver, this is 5-iron, and the pitching wedge from the same golfer. So this is the total torque of the forward-backward axis component and the vertical component here. If I superimpose this arrow here, so this is the torque from the driver condition. As you can see in 5-iron, this angle is less than this angle here. That means this component becomes more important because this is relatively larger than this one compared to the driver condition. So actually, as the club gets shorter, actually the swing plane becomes stiffer. then the importance of this component increases. So the importance of the frontal plane gyrative torque increases as the club gets shorter. And interestingly, in the 5-iron condition, the magnitude does not show much difference from this one here, because the ions are heavier than the driver, although the speed is less, but it's heavier. So we need to generate a similar amount of torque between these two. But when you go to pitching wedge, then again, the direction, so this angle is less than this angle. That means the frontal plane gyrative torque is more important than the horizontal plane torque. And that the magnitude also decreases when compared to the driver condition. So depending on the club condition, you will see a slight different direction and also different magnitude. But one thing really interesting is this one here, swing on the knees. So this is Martin Bogmeyer, and he can generate about 85% of his maximum speed by kneeling. Then, so I get this question quite often. So I thought it may be a good idea to include this in this particular episode. So in the regular golf swing, this is a driver condition, but the two components show similar magnitudes, although in general, the frontal plane gyrative torque should be greater than the horizontal plane torque here. But they are reasonably comparable. So this axis shows the angle close to 40 degrees, 45 degrees. But when you kneel and the swing, then it's mainly, the rotation is mainly about the vertical axis. So let's say this is the actual torque the golfer generates using the ground here. And then most of it is this vertical component. In other words, the rotation, which causes rotational acceleration in the horizontal plane. And then the frontal plane gyrative torque is not much. It's actually a lot smaller than this one here. As I said earlier, we can certainly generate larger torque about the vertical axis by spinning the body quickly. But we don't, because we need to have a reasonable ratio between these two so that we maintain this axis. So although we can generate more torque about the vertical axis, but we don't. So that's something you need to understand. But in this case, because you need more torque about the vertical axis, so it's definitely you can go more. But that's why this can be close to 85% of this one here. But this fact, the fact that you can generate about 85% of your maximum speed kneeling should not be used in discounting the importance of this component. It's basically between the two, we have very different alignment of the torque axis again. So this is the axis of angular acceleration in this case, but this is the axis of angular acceleration in the regular golf swing. But because of the difference in the direction of the axis here, so you can increase this vertical component more. That's why you can generate up to 85% of your maximum speed. But it doesn't mean that this component is not important. Still, in the regular golf swing, this component is the limiting factor. So if you don't use the ground that well, then you will not be able to generate that large torque in this direction here in the frontal plane. So if this is limited, then you can only generate certain amount of torque along the vertical axis or in the horizontal plane. Because even though we can generate more torque, but if you do, then your club will miss the ball by a mile. Okay. So this component really becomes the main limiting factor in golf swing. So that's why I emphasize the importance of the frontal plane gyrative torque. And with the frontal plane gyrative torque, you can really characterize the golfer's swing. And so this is the main focus of my swing analysis. But anyways, so it is important to understand that this torque is still important. The peak torque in this direction and the peak torque in this direction both significantly correlate to club speed. So this torque is also important. But we can go up more if you want, but we don't, because if it's too large, then you have trouble in terms of bringing the club head down to where the ball is. And really what affects the golfer's ability to generate torque is this component. So if you don't use the ground that well, then you will not be able to generate a lot of torque in this direction, in the front of the plane. Okay, so in this episode, we mainly looked at the both the front of plane jerk torque and also the horizontal plane torque here. And then the majority of this torque is coming